All right, everyone. Welcome to the Signals RFC discussion with the Angular team. My name is Mark, and I am joined by Pavel, Alex, Jeremy, and Andrew, all from the Angular team. And we are so excited to be sharing this new milestone with you folks. And we love all the feedback. We've seen tons of feedback so far. So we are pumped up about this. We see people coming in from all over the world. We got folks from Mexico coming in. Eddie, good morning, good afternoon, good evening, good day to everybody. Let's look at this. People love us already. Hello to the Angular team. We love you. Listen, we love you all too. We love the fantastic Angular community. Thanks.
Yeah, I see Denmark, Switzerland, Paris.
Denmark.
Jens from Berlin, who is on the Angular team, doesn't count.
Yes, doesn't count. You're on the Angular team. So many people. Brazil, Peru, Nepal, Italy. All right, friends are here from everywhere. And while we would love to shout out each of you individually, we're actually going to get this conversation started. And we're going to kick things off with Alex Rickabaugh from the Angular team. He's going to take us through the first part of the RFC. Alex, take it away.
All right. Thank you very much, Mark. Yeah. Welcome, everyone. So the Signals RFC is a fairly big, I think it is absolutely the biggest RFC that we've done. And we've split it up into 4 parts. So we'll take you through each of the parts. I have the kind of privilege of presenting the first one here. So the first part of our RFC talks about the choice to use signals for reactivity in Angular. So it starts off with kind of the value proposition, right? Why are we doing this now? Why did we decide that Angular needs a new reactive primitive? So we talk a little bit about Zone.js. Zone.js is how reactivity in Angular works today. And Zones has some really powerful capabilities, actually, and some challenges that we see with it. And essentially, we call out here that Zones doesn't really give us information about what changes in a component. It only tells us that something happened in the application, and then change detection has to go in and kind of figure out, looking at the expressions in your templates and evaluating things from the top down, figure out exactly what it needs to update. So one of our main goals here is to introduce a reactive primitive that can give us this fine-grained information. And that will allow us to do a few things with change detection and with reactivity that aren't really possible with the limited information that Zones gives us. So then we flow into, okay, if we want to introduce this new reactive primitive, what do we need from it, right? What are the requirements here? Kind of central is that it has to be able to tell us about model changes that affect specific components. Zones does not do this, right? Zones only tells us that something happened in the application. It doesn't tell us which individual components were affected. It has to be synchronous. And this is actually really a key one, right? When you have a binding in a template, that binding is displaying something in the UI. It always has to have a value to display. It doesn't make sense to have a binding that says, like, at some point in the future, there might be text here. Your UI should really always have values in it. Reading values must be side effect free. Shouldn't, like, just binding something in the template shouldn't trigger network effects or anything like that. Basically, this means it shouldn't be surprising. It must be glitch free. I love that we have a glitch in the formatting here. I'll have to fix that later. But reading these values should never show you an inconsistent state. And we get more into what that means down the road here. And dependency tracking should be ergonomic. That's another kind of key point here. It should be fairly straightforward to specify what your template depends on. And we have our first discussion point. We'd love to hear your feedback. Is there anything missing from this list? So this has been an ongoing project for us for a while. We've done a lot of research in this area, and we've played around with different, a bunch of different solutions. We looked at, can we make Zone.js better? Can we run, individual components in their own zones or things like that? We looked at like set state style APIs. We've looked at signals. We've looked at using RxJS for this. We've looked at kind of being fancier with our compiler and doing better compiler-based reactivity. We've looked at proxy-based approaches. And in the end, we kind of found that of all of these different solutions that we tried, we liked the experience that Signals provided the most. And this is in some ways not surprising. There are a number of other frameworks that have that do things with Signals. Preact and Solid kind of more explicitly. Vue is very signal-based under the hood. And we see that it works really well in those other frameworks. So it's not surprising that we found that we like the experience as well. So what are signals? Signals are wrappers around values. So they behave kind of like variables in that sense, but they have this extra capability, which is that they can notify you when they're changed. So we talk a little bit about the signal concept and how dependency tracking works. We talked about computed signals. Computed signals are signals that don't get their value set directly. Instead, they kind of read other signals and do computations and derive a value from those other signals. And as a result, computeds can update whenever any of their sources update. So we have an example here of like counter is a good example of a writable signal. Is even, checks whether the counter is even, is a good example of a computed, right? You don't want to update that directly every time you change the counter. You just want it to recalculate as needed. And we have this idea of effects. Effects are kind of the end of the reactive chain when we need to do something in the real world when signals change. For example, like updating the UI of a component, updating the DOM. So signals automatically track dependencies, which ends up being very ergonomic because you don't have to think about it all that much. And this is what allows us to kind of understand, hey, you've changed some aspects of the model, which components are going to need to update because they end up depending on those things. So why does this work well for Angular? Well, we have that fine-grained information that we were looking for, right? Know now which components were affected whenever you make a change to the model, and that allows us to kind of optimize the synchronization process. They are synchronous, great. They don't trigger side effects. Signal implementations are glitch-free, so you'll never see a case where like the counter is odd but is even says that it's still even, or vice versa. They track their dependencies automatically, and they can be used kind of across the board. Signals are not something you can only use in components. You can use them in services. You can use them in directives. They're not kind of limited in their scope. We also see some other things that weren't explicitly in our requirements, which we also like. Computed signals can be lazy. They can only evaluate when they need to. That leads to some nice performance characteristics. There are relatively few concepts for developers to learn. And they play well with other reactivity systems. And that's important to us because in Angular, we have RxJS that people use to kind of trigger on-push change detection. And Angular's current zone system interoperates well with signals. So how's Angular going to use signals? This section kind of talks about like what benefits are we actually going to get out of this? And it's a fairly big change. They affect quite a few aspects of the framework. And we start off by kind of talking about the interop with zones, right? Zones and signals will need to work together, even though they have very different assumptions about how data flow works. And that's an interesting problem to solve. So we think the right boundary here is to switch the reactivity models on the component level. So we will have signal components and zone components. And I'll say component here, but really directives also kind of follow this split. And you'll be able to use both in the same application. You'll be able to have signal components with zone children and vice versa. And this allows you to kind of gradually, if you want, start using signals for new components, start converting existing components one at a time to signals. And for libraries in particular, being able to convert your libraries to signals in a backwards compatible way. So the big kind of new selling point of Signal components is local change detection, being able to do change detection that's not dependent on this top-down Zone.js traversal. And that works because there is only one way to trigger change detection in a Signal component, which is to change a signal that the template depends on. So we call this the golden rule of Signal components. And in fact, we're going to do change detection even narrower in scope than specific components. We're going to change detect individual views. So if you're not familiar with views in Angular, this section kind of goes into some details of what a view is. Effectively, it is a static set of UI. So for example, this whole template is one view. But if I add an ngIf in here, then I kind of get an outside view, which is the div and the labels. And then the ngIf body is a separate view. And that's useful because even in something like a for loop, every row of the for loop is a separate view, which is really nice when you think about local change detection, because it means we can change detect each row of a table separately if we need to. And there's some argument here as to why we're doing per view change detection. We could have done deeper, right? We could have said, oh, we're going to change detect each element individually, or even each binding. And why did we pick view, right? We picked view because we think it's the best trade-off. We think it gives most of the benefit of tracking at a very fine-grained level, and because it composes really well with the zone change detection model. Because these things need to work well together in the same application, it makes sense to have them kind of both functioning at the same level of granularity. So the next kind of really nice feature of Signal components is that you get Signal inputs. Inputs are things that can change over time, and so using a signal for them is fairly natural. And this has some really nice properties. So in zone applications, when you bind to an input, this expression gets evaluated during change detection, which is actually kind of late in the life cycle of making an update. And this is why Angular has these expression change after checked errors that end up being kind of fairly well known. Because when this input changes, you are kind of changing the model of the downstream component in the middle of change detection, and that means you're sensitive to the order in which things are checked. Signal inputs don't really work that way. When you have a binding to an input in a signal component, assuming you're using all signal components and don't have zone components in the mix, these bindings behave as computed properties. So this user profile component is receiving the user data as a computed expression of this thing, which means this parent template actually doesn't depend on this data at all. So signal inputs resolve kind of before the whole change detection process starts, which is nice because it kind of dramatically reduces the risk of expression change after it's checked, because you kind of fully synchronize all of your inputs before you even start the change detection process. Input bindings won't trigger change detection of the binding component. That's kind of nice. They also don't automatically trigger change detection in the component that's getting the input, only if you use that signal in the template, right? That's the golden rule of signals. So in addition to inputs, queries are signals. That's kind of fairly straightforward. Queries already have the query list and the changes, observable, that tell you when the query updates. It's natural in signal components that they would just be signals. And yeah, you can freely mix signal and non-signal components in the same application, even in the same template if you'd like. As long as you observe this golden rule of signal components, right, that you have to set a signal to change detect them, change detection should work in between them. There are some kind of caveats there. There are certain APIs that kind of assume global change detection is going to happen. ng-model is one such example. If you take an ng-model directive and get a reference to it and just write out the value, this doesn't work in a signal component, right? You are not reading a signal here, so you're not causing change detection to happen. Yeah, and the last kind of nice thing is if you manage to convert your application entirely to use Signals, you get the benefit of being able to switch off Zone.js entirely, to not ship this library and use it at bootstrapping time, which is it's Zone.js is not a trivial amount of code. So there's some real wins there. So that's kind of it for the first RFC. There are some FAQs. I think I probably won't go through them and hand over to Pavel to talk about the.
Alex, right before you do that,
yeah,
we have a few questions that I think would be good to just touch on before we move to the next RFC. All right, let's start with the first question from Pablo. Is unit testing going to change with Signals?
It probably will. One of the challenges with unit testing today is kind of having to manually detect changes or flush, because you're kind of running outside of a browser context where Zone.js is helping you. We think Signals can be an improvement here. It's largely an unexplored area in our design. I would not be surprised if we had another RFC in the future related to testing specifically. So stay tuned.
All right. We might have to come back to this one from Stanislaw, which says, awesome. Should we expect some React-like hooks or even function-based components? I think we should save this question.
Yeah, the third RFC talks about like, what does this look like in actual components? So I think we'll
come back to that. Stanislaw, we're going to come back to your question. I'm going to save it. Don't worry. We care about it. All right. So here's what Marcus says. I read Rx glitches aren't actually a problem and that it's rather a result of non-optimal coding style. It's free from glitches, prioritized because glitches still seem to appear regularly in the wild.
Yeah, so maybe it would be useful to talk about glitches specifically. And there's a whole section in the frequently asked questions here on RxJS and glitches. But it's fairly easy to demonstrate glitches in RxJS. So here we have a counter behavior subject. We have isEven that pipes it to basically a true or false, depending on whether or not it's even. And then we use combine latest to make this message, right, which takes the value of both of these observables and produces this message that says, the counter is even or odd. And if you subscribe to this thing and then next it an odd number, you actually get 3 logs, not 2. You get the 0 is even, you get the 1 is odd, but in the middle, you get this 1 is even. And that's because when you next to the counter, combine latest runs twice, first when the counter updates and then when is even updates. This is not surprising to anyone who's worked with RxJS. And it's actually not even, I would not say this is a bug in RxJS, right? This is not something that Rx is doing wrong. This is more an artifact of RxJS is based on streams of events, right? When you next a counter, you're basically triggering an event in the system that says the counter is updating and everything else is processing that event. And so combine latest is doing exactly the right thing here. It receives 2 different events and it runs its message processing, it creates the message twice. The message subscriber runs twice. What the glitch here is when you're trying to use this event system to represent synchronous state in the application. When I have these 2 things, which really aren't separate event streams, but are trying to represent one unified state, then this results in kind of these intermediate events that don't really fit the model that we want to show in our UI, right? They don't represent kind of a settled state of the application. They're in progress computation. So it's really trying to use event streams to represent synchronous state where you run into these kinds of glitch problems. And you can always refactor this RxJS code to not have this issue. You can use like with latest from, I think, instead of combine latest. But this is something you do have to be aware of if you're using a event-based system to model state.
Okay, let's see if we can go through a couple more questions before we move to the next RFC. Okay, so Signals allow CD per view. So I guess change detection per view, not per component, right? So which seems finer grained. So is this better? So just to clarify for folks, what do you mean by change detection per view and not per component?
Yeah, so today when Angular runs change detection, we're actually kind of here, right? We are running every template in the application, evaluating the bindings and checking, did this change? Do we need to do some update in the browser, in the DOM, based on the new value of the binding? And that process happens by kind of going down through all of the components in the application and then all of the views within all of the components and checking each one, all of the bindings in that particular view. So with signal components, we actually can be much more specific about which views need to be checked, because we know which views potentially have changes and which views could not have been affected when you set a signal. So we can make change detection more efficient. It can do less work in order to update the UI correctly as the result of a model change. Finer grained is not always better. So one of the kind of points that we make here is this dependency tracking actually is not, you don't get it for free, right? Being able to know specifically which tiny little thing changed adds a lot of overhead. And so we specifically don't want to get into like, let's check each binding separately, because that might require too much memory, too much, bookkeeping of knowing which, what the dependencies of each individual expression are. And you don't really get a lot of benefit in checking and updating a specific binding versus a specific view. There's a much bigger change going from like the whole application to individual views than there is going from individual views to individual bindings.
All right, Alex, thanks so much. Now we're going to jump over to Pavel. Pavel's going to share on the next one. Thanks, Alex.
Cool.
All right, Pavel, over to you.
Thanks. I just can't believe that we are sitting here in front of this RFC, because literally we've been discussing those APIs for months. So Alex was painting the picture, like a broad picture of how signals fit into Angular and in the entire change detection on other subsystems. But what are those signals, right? Like, how do we create them? How do we respond to the changes? So that's the second sub RFC, where we specifically dive into all the APIs that we will be using and how they behave. And the good news here is, before I start scrolling through RFC, is that there are really only three fundamental concepts in the API surface, right? Like, we've got signals, we've got computed, we've got effects. So we went into very detail, like we described every single option that you've got the API, but it's good to keep in mind that at the end of the day, there are just three fundamental concepts here. Okay, so obviously the signal is at the center of the stage, and it is a very small API. It's essentially something that you can ask for a value. We've chosen to use getters to say hey, give me the latest value. And on the framework level, we also added a symbol, like a branding through a symbol, so we know inside the framework that this getter function is a signal. So that's really, this getter is the one and central concept. So how do I create a signal? Well, maybe before creating, you can ask for the value from the signal, but the question is how do I update the value, right? Like, if I would be asking for the value, it will always be the same, then it's not very interesting as the concept. So we do have a specialized type of signals that we call writable signals. Those are the signals that you can update value to. And fundamentally, there is one operation on the writable signal, which is set. It's like, oh, I'm going to give this primitive a new value. So when someone asks again, I can give you this new value and notify anyone interested that there is a new value. And what I wanted to highlight here, that this writable interface is broader than the set method. There's also an update method and mutate method. And people will, when we were chatting initially about those APIs, people were asking, oh, like, why do we have so many methods to change the value of the signal? So I just wanted to say that the set is the fundamental operation, and the rest of the APIs here are just pure convenience. And I will show you in a bit. Now, I can create those writable signals by calling, signal creation function. Signal gets an initial value. I can replace it. And again, there is another way of setting through update. We will have a example of how you can write update through set. We do call out a naming discussion around signals that we had. So what we are essentially saying that the signal as the concept is this thing that you can ask for the new value. The writable signal is the specialized version of it. But then, you might say, and rightly so, that like, oh, so why you are using signal creation function to create a writable signal? So we go into this discussion. It's not ideal in terms of naming and understanding of the concept, but it also was we use the short names and the very convenient names. So there is this bit of trade-offs here. Right, so there's this whole discussion about the naming. You can like have a look at it and give us your thumbs up, thumbs down, or opinion, other alternatives. Then again, when we create a signal, we can pass the initial value, but we also can specify how signals think about equality, right? Like, so we can pass a specialized equality function. So when I call a set, the signal will consult this equality function. Like, okay, you're giving me a value. Did it really change? If not, then like I'm going to ignore you. But like if it changed, I'm going to propagate this notification of the change. So that's one of the options on the signals. There is a part that says, again, like the dot set is the fundamental operation that changes the signal value. And there is a section just showing that update is the convenience. You can always, like, you can, if you prefer, you can ignore it and say like, hey, like the update type of mutation can be also expressed through a get. So we are calling out, like that's the kind of calling out the discussion point here. Like, do we want to have an update? It's a new API surface. It's convenient, but maybe, it's another thing to learn. The third way of changing the value of the signal is something called .mutate. And this is slightly different compared to set and update. It's actually makes sense only for signals that hold bigger objects like arrays or like a JSON that you might have pulled from the server. And it gives me ability to mutate object in place, but still notify the whole system that something changed, right? Like, so in this sense, signals do not require people to use immutable data, which again, we leave this choice to people. Now, there is the large chunk of this Signal API devoted to how we decided, or like how we presented as our favorite, that the signal is represented by the getter function. And we go into the very fine details of those decisions. Honestly, we've spent months and months agonizing about those choices. There are trade-offs, so I just won't go through all of them, but we looked at the getter functions. We obviously looked at the dot value that other signal libraries choose. We looked at the usage of decorators. That was a very common question in the pre-RFC. People were asking like, okay, why not decorators? So we were trying to provide some information in there. There is another API that is used by Solid.js and might be familiar for people using React, this doesn't work for classes, so we kind of discarded it. Proxy and so on. So there's a big chunk of this RFC. We know that people have preferences in terms of syntax, and effectively some of the syntaxes work in certain situations better. So we just wanted to put on the table all the considerations that we've been going through, so people, like with all those considerations on the table, can kind of have more informed preferences. Cool. As soon as we know what the signals are, the rest is like really simple, because there is this concept of computed signals, which essentially derive the value based on the dependencies, right? Like, so I can have a computation function here. I can reference any other signals. They will be my dependencies. When one of my dependencies change, then the computation function runs again, right? Like, so this is this very efficient computation in the sense that it only reruns, or it recomputes only if one of the dependencies change. So one of the things we hear is like, oh, I'm afraid of calling functions too often, especially in Angular templates, because maybe the computation will run too often. That's not the case here, right? Like, the computation runs only when one of the dependencies change. Computed has very simple signature. I'm providing whatever the function that does the job, and I can also provide a quality function, right? Like, because what might happen is that the is-even number here, if I set the counter to, I don't know, to number 1, then obviously the is-even will change. But if I set it to 2, it still is even. So this computed didn't change. So it does not to have like kind of recompute the other dependencies here. So computeds also have this notion of equality, and this equality can stop propagation of this notification in the system that something changed. What more about computeds? They are really straightforward. I think what we are calling out here, that those computation functions should be like those small pure functions. We are having some checks in place. So if you trying to create another computed from a computed, we will raise a warning. We obviously cannot detect all the changes where computed might get into the mutation business, and thus all maybe do some side effects. But we will keep highlighting that the computation functions should be pure. The current implementation of Signals has some nice properties, or at least the properties that we like a lot. So our computations are lazy. So I've got this computation function. It might have dependencies, but the computation function will not run if no one reads it, right? If no one is interested in the computed value, we will never compute it. So we are trying to defer work to as late as possible. Computations don't have to be like destroyed in an explicit way, and Alex mentioned glitch-free. Batching, I don't think I will talk about it that much. Okay, the third API and the final one. There is an effect. So computation, you can think of the computation as like produce a new signal when one of the dependencies change, or do computation when one of the dependencies changed. Effect is kind of poorer version of it, in the sense that it just like will run some code in response to dependencies change, but without producing a new value. And effects are really this end of the reactivity story, right? Like those are useful to log something to the console, or maybe write to the DOM, or do the network effect, but they are not supposed to be like meaningful. Those are leaves in the interactive graph. So again, very simple example. I can do work, like I can specify the do work function for the effects, and again, this is the primary API. Again, if I call one of the signals in this do work function, those signals will be considered as dependencies. Effect reruns only when one of the dependencies changed. So again, I mentioned that there are a wide variety of usages. What is good is that you can return a cleanup function from an effect. So since effect is like do some work function, you might start the work, and while the work is in progress, one of the dependencies might change, And then FX is like, okay, well, like, what should I do? I've got some work in progress, and you are telling me to start some more work. I cannot handle too much at one time. So you like this returning the cleanup function gives you ability to say like, oh, I'm stopping the work I've got currently in progress, and I will start a new one because I've got the new set of dependencies. The effects run when the dependencies change, and that's the only guarantee that we make or like that we can give you in the library. So you are guaranteed that effect will run when dependencies change, and it will run at least once, but we are not specifying anything about the exact timing. And more probably, we will be changing this timing as the implementation and design progresses. So I'm just trying to say that the exact timing of the effect run is not that important and probably shouldn't be relied onto. Cool. I think we're getting close to the end of the section. We just, well, you can also destroy manually effects, right? Like you scheduled maybe some work, but like finally you say like, oh, I don't want to do it anymore. Then you can explicitly stop. Then we did add on the pretty much last minute some of the checks for the effects to avoid common problems. And one of those common problems is trying to write to a signal from an effect. And the way we think about effects is this end of the reactivity story. So it's kind of strange, like, okay, we are saying the end, and then like if you write to the signal, then we are just kind of jumping back, right? Like, so there's potential of creating loops here, or other unintended data flow situations. So that's why by default we will block writes to the signal. If you really believe that that's desirable, then you can pass the additional options. There is more in the frequently asked questions. There is good discussion going, but I think that's the overview of what we've got here for the pure API and the functioning of this library. And I don't know if we've got questions that we want to cover.
Pavel, questions. Do we have questions? All right, friends. So friends at home, thank you so much for submitting your questions. We are keeping track of them. We're going to try to answer as many as we can. If we don't get to it in the segment that we're talking about, we'll try to get to them at the end. Someone asked if we're going to be recording the session. Yes, so you'll be able to watch the replay. After we're done live, the replay will be live on our YouTube channel. So you'll be able to catch it there. So we'll get to your questions. If we answer them after you stop viewing, we'll still try to answer them. All right, Pavel, so many questions. Let's start with...
That's perfect.
Okay, let's start with this one. Template bindings must always have a current value. How would we achieve a use case like this one using signals? For example, showing the stock price changes from a WebSocket.
Right. So again, when you create a signal, you have to give it initial value, right? Like so there is like the API doesn't allow you to create a signal without the initial value. But there might be cases that there is no good default value, right? I mean, if I really need to pull some information from the server, that maybe like I cannot guess. I like probably in terms of price, that might be 0 might be a good default value, but also undefined might be a good default value. So obviously you've got full control in terms of type that the signal holds. It can be as small as, like one counter here, number, or it can be JSON from the server, or it can be JSON from the server or undefined. So I would say create a signal with undefined. When the information comes back from the server, you set the information that you've got.
Okay, Chaos Monster says, would you need to do signal components bottom to top, or can you just intermediate nodes in the tree?
Yeah, it's per component, so you can mix and match. That like we kind of recognize that in big applications, you've got many components, like you use third-party libraries. We would not like to force, oh, hey, this is the entire subtree that you need to take care of. So it's per component.
Okay, excellent. Are you considering signal plus custom change methods? This is from, I guess Mike F. Pearson had an idea like this, and Dimitri wanted to bring it to the top. What do you think about this, Pavel?
Right. So essentially, I like the way we think about signals is this box for the value, right? Like I can create it with the initial value, and when I change the value, it notifies dependencies that like, hey, maybe you should recompute. Now the mutation or the change methods or write methods that we kind of came up with is just like set update and mutate that we saw in the API. I think it is an interesting idea to have like more specialized signals that people like, maybe I've got like a specific set of changes that make sense, right? Like maybe I can only provide numbers from some range. So I cannot accept certain things, or maybe, the change is very complicated as the operation. So I don't want to give people complete freedom how they can change. So I think we'll be looking into it, like how people can create their own more specialized version of signals, or maybe this will end up in the realm of state management libraries where you've got like more specialized mutation methods. So it is an interesting idea, and I think we will need it, but no concrete plans for now.
Okay, great. Here's a comment. And the comment is kind of a question, but maybe just a few sentences about this. So this person wants to know, kind of says, well, can we get rid of Zone.js through Signals?
Right. So that's one of the biggest driving forces for us, right? Like, because Zone.js gives us this very broad notification mechanism, like something might have changed in the applications. With Signals, we get the notification mechanism that is very, very precise. We know that something changed. We know that some component is reading this value. So we know that something changed, and we know that who is interested in the change. So we essentially can both replace Zone.js, but also use this more precise information to our advantage.
Okay, sounds good. All right, let's do one more question. And friends, remember, if we don't get to your question through this segment, we have a big Q&A at the end. So we're gonna do as best we can. Let's see. Oh, this is a really great question. Is Signals going to be in the Angular core, or is it going to be like a first-party library?
Right. So like many questions in the pre-RFC was like, why did you go with your own Signal library implementation instead of taking something off the shelves, like MobX or Preact did excellent job on their Signal library. And what you very quickly notice when you try to integrate those things in the framework is this integration is very, very tight. So it's like taking something third party would need a lot of massaging. The other thing is that those Signal libraries, they are popular, but they are still very new. In the sense that we are still figuring out the exact timing, when the effects should run, should computers be lazy or eager, and each library is making slightly different decisions. We are still discovering algorithms. So I see it as the good things, right? Like those libraries are relatively small, like it's probably less than 1,000 lines of code. So I see it as the good thing that people like try to write it on their own, discover new patterns, new algorithms, and tightly integrate it in the framework.
Okay, we're going to get more from Pavel at the end with the Q&A, so hang tight. But up next, we have Jeremy Elborn, the fantastic co-host of the gaming stream, so you folks know and love Jeremy. Jeremy, over to you.
Hello. A button that does that now. It's fun. Mark, why don't you stay in here and hang out with me while I do this?
All right.
Because I feel like as I go through this, there's maybe some opportunities that are like, well, we can stop and ask questions as we go, and maybe even you have some questions. I like when we have more of a conversation.
Sounds good. I'm here for it. All
right. So this is a fun part of the RFC. This is trying to give you a feel of what it is like to write a signal-based component or to use signals inside of your components. And so we have a lot of proposed APIs here. And I want to say up front, this is absolutely a proposal. This is nothing that has been decided yet, nothing that has been implemented yet. The whole point of this RFC is to get all of your feedback on this. And we are listening very carefully to that feedback and expect to absolutely change some parts of this based on what we hear from everyone. So with that, let's go ahead and dive in. So in a signal-based world, you will have signal-based components. And these are slightly different from the components that you have today. You will mark signal-based components as signals true. And we know that this is a little bit boilerplatey. We have a note here, especially if you're having like signals true, standalone true. Yeah, like we don't love it either. And we're still trying to think about ways to make it more concise so you don't have to write that all over the place. But for now, this is just kind of our like proof of concept working thing. So don't worry about that too much. Using a signal inside of a component, you've already seen Pavel talk through the Signal APIs themselves. And so you're just using those APIs inside of the component. So you create a signal as one of your class members here, and then you can just read it in your template, and you can update them inside of, event handlers, whatever else you're doing. And all of this will just, stay up to date as you expect in Angular. And this signal updating here, this is the thing that's driving change detection for this component's view right here. So you may have a couple of questions, right? If you've been using Angular for a while, you see like, hey, we're calling a function in a template here. People have told me over the years that I'm not supposed to call functions in templates. Well, that doesn't really apply here, right? So the whole notion of calling a function in templates being slow is because when Angular was doing change detection with zones, it would rerun that function over and over and over and over again and recompute the expression in order to see if it was different from before and if the DOM needed to be updated. That doesn't really apply anymore here, right? What we're doing with this function call is we're just reading that signal value, which in and of itself is very cheap. It's just really like returning a property that's inside of that signal. And the signal updates here are the thing that is actually driving those updates. And so this isn't something that you have to worry about when calling signal getters here. And you might also be wondering, hey, like I'm calling this getter in the template, could Angular just automatically do that for me? Like Vue does something similar to this, where it will automatically read the .value property of proxies, the proxies they use for their reactivity system in Vue. And the answer to this is no. And there's a couple of reasons for that. One is that we want to leave the door open for components to be able to bind actual signals themselves instead of reading the values out of a signal. And you can even have situations where you have a signal of a signal, which I know sounds kind of silly, but can be really useful if you want to pass around more sophisticated things. And the Angular framework, the Angular compiler, turns your templates into JavaScript code at compile time. However, the tracking mechanism for signals operates entirely at runtime. And so if you had some situation like this, then you hold on, I'm getting some chats.
Can you zoom in just a bit? I think the stream says they can't see it just as wide. So maybe
my browser window. Got it.
Yeah, there
a
we
little
go.
Better.
Looks good. Mm-hmm. That's better.
Cool. All right. I think we're.
Oh wait, no, the streets want more.
More. Oh boy.
They want more.
Browser window a little bigger.
All right, that looks good.
That's 200.
HTTP
okay.
200. Okay.
Yes, 200. We're good. So you might have a situation like this, right, where you're having a binding. It's like some object, some method that you're calling, some property, and then deep inside of some method here, there's like a signal read somewhere in the middle. At compile time, Angular would have no way of introspecting on this very deeply and figuring out that this is a signal read and thus like doing any sort of automatic unwrapping, right? There's too much opacity for the framework to really dive into, unless we were to, in some other way, restrict what you could bind to in your templates. And we don't want to do that.
Jeremy, let me jump in real quick. In that example where some method is, can you just explain for the stream, what that this.items parentheses bracket, just explain that line of code in Signal language for us?
Oh yeah, this is just some contrived example I made up where you have a signal that has an array of strings, and then you have some method that is returning. So we're getting that array, the current value of that array. We're getting the first element, and then we're calling to uppercase on it. So it just, some silly example I made up to show that you could have a signal read buried very deeply inside of some expression that would be really difficult or impossible to know about at compile time. So here's another thing that we're interested in getting feedback on that is potentially confusing about using signals and components. So you've seen we have signal reads inside of template expressions here, so you have count, but you can also still have regular properties in your template expression. So here we see count is a signal and name is just a regular old string, and we combine both of those in our template. The thing is, if you're used to writing Angular today, right, you know that in zone-based Angular, anytime you change this name, then your template is going to update. It's just, that's what zone does. It's just overzealous with how often it checks everything. And so it's going to catch anytime you change this and update your template. But in a signal-based component, the only thing that's driving whether or not this component is going to be updated is whether or not a signal is written. And so in this situation, if you were to change count here with like an update method, and you say you were also to change this name here, both of them would update in your template. But if you only changed name, it would not update. And you might expect, right, like this, the reason I even think this can be confusing is that in a signal-based component, you might think that the only expressions that are only ever going to change are expressions that change due to signal reads. And the reason for this is because we are using signals here as a mechanism to drive that this view is being checked, but the bindings themselves still work the same way that they've always worked in Angular, which is that when the template is checked, we update all of the dynamic expressions based on their current value. So there are some things that we are considering to help mitigate this, right? Like we can raise an error at runtime if a template expression changes without depending on a signal read, which would basically make this an error condition here. We could use something like the language service to raise a compile time or really a developer time warning if you try to bind to something like this that's not marked as read-only. But that is limited, obviously, because if your read-only property is buried very deeply inside of something, you wouldn't be able to detect that. So I see a question here is, will you be able to force change detection so that name will be updated? I don't have an answer for that yet. We haven't gotten very deep into what like forcing change detection would be like. However, I will say that would very much not be aligned with the intent, the design intent behind signals here, right? If you are going to change name, you should put it in a signal. That's what they're for, is for modeling your state that can change over time. You would only really want to have a non-signal value like this if you know for a fact that it's not going to change. Cool. So moving on, computed properties, Pavel talked about these. They are pretty simple. You define a computed, you use it in your template with a little getter call, and it just works. The computed will only be reevaluated when any of the signals it reads have changed. And so I won't spend a lot of time on that. Although I will say there are a lot of usages of the ng-on-init and ng-on-changes lifecycle methods today that will just go away with computeds, because there are tons of situations where you would say an ng-on-init or ng-on-changes, read some inputs, and then do some computation on those values and cache them into another property. So you can use that property in your template without calling a function that's going to reevaluate in your template every time. And so those situations, you would just replace those with computeds, so that you are kind of declaring this more like declarative computation that you can reference directly in your template, and the framework takes care of like only updating it when it needs to be updated. So here we get to the big part of signal-based components. And this is really, in my mind at least, the biggest thing about what makes a signal-based component signal-based is that its inputs are signal-based. So when we say input, we're talking about what today would be, you'd use the @input decorator So this is an API that is in signal-based components replacing the input decorator. So I will also clarify, everything we're talking about here only applies to signal-based components. That's it. Signal's true. Existing components, zone-based components, stay exactly the same. Nothing changes about those. And there's no plan to get rid of those or deprecate them or anything like that. Like, this is a purely new addition to Angular. So you can define an input by calling this input function here. You can specify the type with the generic here. And so in this case, you would end up with a signal of like string or undefined, since you're not passing a default value. Or you can pass a default value, in which case you would just get a signal of string. And you can also pass a config object as the second argument here, where this config object has things like alias, which is what you can pass to the input decorator today. You could pass required true, which is something that is landing in v16, is having the ability to have required inputs and so on. And a couple of like key notes about this. One is that there's no decorators, obviously, here. So we're going to talk about decorators towards the end of this section, or since it applies to a couple of other APIs as well. Another mention is that this input function is actually, it has special meaning to Angular and isn't just a regular function, which we'll also talk about at the end in more detail. And the signals you're getting from these inputs are read-only. They do not have methods for set, update, and mutate, as you saw. And the reason for this is because we think that this is kind of the right way for inputs to behave. And this means that your input value is always going to represent the thing that is currently bound into that component. And if it is writable, then that state is only really reflecting whoever has written into it most recently. And so you would lose access to the thing that is currently being bound in.
So Jeremy, would this potential change bring us more in line with the concept of other frameworks? We have like the props, where props are immutable, read-only, and then you don't do anything like that?
So input is honestly just Angular's word for prop, right? Like those two concepts are exactly the same thing. It's like, this is you can even kind of think of it as like a parameter, or like this is an expected value for this component. Honestly, we've even discussed renaming inputs to props, but that might be just a little bit too much. So, but yeah, so in React and in Vue, just as examples, their props are read-only, and this is moving in that same direction for inputs here. So that said, we are also introducing a brand new thing. Again, this is all part of a proposal, but introducing a brand new thing called model inputs. This is a new type of input. So it's still an input, but it's a different type of input. And model actually creates a writable signal for you. It gives you a writable signal. And so here in this example, you can define a model. We'll call it checked. And we can bind that into our template here, like whether or not it's checked. And we have this toggle method that updates this checked and just toggles it between true and false. And we have the component here. So this is, we'll call some checkbox up here. And so down here, we have some page that is binding to this checked property, but it is using a two-way binding. And it is passing not a raw value. So we have this isAdmin signal here. It is passing not that isAdmin's raw value, but it's passing the actual signal itself. And so what model gives you is a way of creating an input that supports two-way binding. And with this two-way binding syntax, by virtue of passing the signal, is that the component is expressly participating in this contract to say that this two-way binding is occurring. So when I use this two-way binding syntax and pass my signal, I'm saying, as this like some page component here, is like, I know I'm participating in two-way binding and that this component is going to write into this signal. And now this checkbox can update its own state, and that will propagate back up to the page that is binding into it. And let's see, you can also use one-way bindings with model inputs, and that actually just makes them work the same way that Angular inputs work today. So here, if we use a one-way binding on this checked property that we had earlier, and we look at isAdmin here, this checked is always just going to reflect whatever was written into it most recently. So whether that is coming from this SomePage component, or if it's coming from this checkbox here. And again, works the same way Angular does today. So this is probably a good stop. It's a good spot to stop and ask for questions.
Lots of questions, lots of comments. I mean, we're probably going to have 30 queued questions, so it's going to be a big Q&A. But right, so this is aligned with what you're talking about. We just put in 16 next.4 support for required inputs. Will signal inputs be required by default if they do not have a default value?
So no, they will not be required by default. Required will still be, inputs will still be optional by default. And if you don't specify a default value, what that means is that the type includes undefined by default.
Sounds good. Oh, here's
so yeah, it works the same way as inputs do today.
How does that model input tie in with the control value accessor?
So model inputs are completely and entirely unrelated to forms, right? So we know that today ng model as a directive lives in the forms package and is like strictly associated with using Angular forms. That is not related to this new concept of model inputs at all.
Okay. What's up, Starving Musician? Shout out to you. Good to see you again. Signal would be available as input on changes.
This is coming later. We're gonna get to Lifecycle later in this section.
All right. Okay. So let's do this, Jeremy. Let's have you continue because we still have one more section to go with Dylan Hunt.
More than one section to go.
No. Sorry, one more segment. Sorry. Yeah.
Okay. Gotcha. Okay. We're blasting. All right. We already talked about inputs being read only. Input configuration. This is getting in a little bit in the nitty gritty, but there's some API open questions here about setting default values or initial values for inputs. And I will recommend that people go check out the RFC to read about this part, because I don't want to rabbit hole too deep on it right now. So we're going to go through a couple of quick sections now. So
I think it's worth to talk about why no decorator, because there were quite a few questions about
that's at the end. That comes at the end. So we're going to talk about why no decorators at the end. So Angular queries that you might be familiar with today include viewChild, ContentChild, viewChildren, ContentChildren. These work, for the most part, exactly the same way in signal-based components. But instead of the decorator, again, we have this more function-style API. And instead of getting either for the singular, so viewChild is the singular, instead of that just giving you the raw value, you get a signal of that, the thing you're querying for. And similarly for the plural queries, like viewChildren, you get a signal of an array of those results. And this is, again, we're talking about signal-based components. It makes sense for queries to also give you signals, because the result of a query is something that can change over time. And so that signal value can participate in the rest of the signal reactivity system with the framework. And this does mean that the query list API is just not something that you have to deal with in signal-based components. But it also makes it much easier to deal with changes to these singular queries over time. So today, you don't have, the query list does give you an observable of changes, so you can react to changes over time, but the singular versions don't. And so the signal just kind of is more consistent here. So then we'll move on to outputs. Again, the API is changing slightly here, but outputs aren't actually affected by signals at all, right? So The reason we are even making any change at all here is because we just want to keep the API symmetry between inputs and outputs. And so rather than saying, at output equals new event emitter, there's this more concise API that is just something like saved equals output of, and then, whatever type you're using, or whatever config settings you want to set on your output. And this works exactly the same way as outputs work today. Like this output function is just creating an event emitter. There is nothing changed. This is not creating a signal. This is not changing how outputs work in any way. It's just a different API to be more consistent with inputs. Lifecycle. So this is the kind of last big part of this section. So today, Angular has 8 different lifecycle methods that hook into different stages of Angular's change detection. So off the top of my head, see if I can remember. There's on init, ng on changes, do check, after view init, after content init, after content checked, after view checked, and on destroy. And these methods are very tightly coupled to the way change detection works in Angular today. And as we've already talked about, signal-based components, change detection works very differently for them. And so it doesn't make sense to have the same lifecycle points as zone-based components inside of signal-based components. And so with that, we're proposing here a new set of lifecycles that you can use in your components. And so these are all kind of just listed here in the constructor of this, although some of these don't have to go in constructor. This is just kind of a way to show them all together. So starting from the top, we've got after init. This works roughly the same way as ng on init today, is that this will run once all of your components inputs have their initial values. And I'm actually going to just go to the bottom. There's also before destroy. This works identically to ng on destroy. It will run before the component is destroyed, so you can do any cleanup or deallocate anything, things like that. We have effect here, which is included in this lifecycle section because there is kind of a lifecycle scheduling aspect to it. But as Pavel already talked about in the signal section, this is a way you can perform some sort of imperative action based on signals changing. So for example, here, this effect, we are saying console.log this.firstname. When you run this effect, this will be scheduled to run once. And then in the future, it will run anytime this first name changes.
Hey, Jeremy, quick question about effect. Because we saw it isolated in examples, do we need to always define our effects in the constructor?
No, not effects.
Okay,
in the constructor in this example, just because I wanted to put all of these right next to each other.
Is there a good place to define your effect when you're writing your code?
We will probably develop some best practices about this, but we don't have anything formalized yet. But probably not. Don't ever render an effect or register an effect inside of another effect. Probably not something what you want to do. Cool.
So not the effect that you want.
Yeah, right. It's a good one. So then we have a couple of really all of these next 3 are kind of just 3 different flavors of the same idea. So we have after render. And you don't actually have anything that lets you do this in Angular today. People will use something like after view init for this, but it's actually not really what you want. It doesn't mean the same thing. So after render will run after the DOM of all components has been fully rendered. And I want to emphasize that all components, so not just this component, but all components, right? When rendering has completed. And this is for when you just absolutely need to do something with the rendered DOM. So an example here is maybe you need to focus something in your DOM. This is when you could do that. Or you want to do, get bounding client rect because you need to measure something inside of your DOM for some reason. This is where you would do that. And then these next 2 are just kind of alternate flavors of this. So we have after next render, which is the same as after render, except it only happens once. And so again, you could call after next render anywhere, right? You could call it in a click handler or something like that. and just say, okay, like whenever the next render happens, I want to like run this code, and like only run once so you can touch your DOM. And similarly, we have after render effect. So this again will run after render, but it will be using the same concept as effect, so that you will run this and it will schedule this effect to run after render once, and then for subsequent renderings, it will only run if the tracked signal here changes. But these are all giving you a way to, if you need to touch the DOM after rendering, after Angular has finished rendering, you have a way of doing that. But all of them, again, are only, they're running after everything has finished rendering, not just this component.
Hey, Jeremy, before we move on, I see a lot of feedback about these changes in general.
Yeah.
All right. Can you comment on the idea that we're still figuring out this, or like at least let people know what phase we're in terms of implementing changes like this?
Yeah. So we are in the phase where we think this is the direction we want to go, and we have some reasons for why, and we're interested in getting feedback about this direction. So I've talked about, like, I've explained what we have here, but let me talk a little bit more about why. Why are we doing it this way? Because the thing that's probably in your mind is like, I don't like that, right? I don't like that these are in the constructor. Like, why is my constructor so complicated? Why do I have to put all of that in there? So first of all, you don't have to put it all in the constructor. So the effect, the after render effect, those don't need to go in your constructor. They're just here in this example for like having them all in one place. So that's one part of it. The after init and after destroy and after render, those are something that in this proposal would go in your constructor. And so you may be wondering, the most obvious thing, like, why aren't these not methods like we have today? Why are they like not just class members? And so we have a couple of reasons for that. I will scroll down here, this whole section, why not class methods? So first is that class methods can only be implemented once. So with these, you can actually have like multiple blocks of like, after init destroy if you wanted to, for different purposes. Although I will like fully acknowledge, right? Like it's not a big deal to have like your ng on init or ng on destroy and call out two other functions in there. So that is not a huge argument, but the second one is really more of a forward-looking thing for us, is that class methods are tied to classes as an authoring format. So this is a kind of an interesting spot we find ourselves in, because we want to introduce signals and the Signal APIs and the signal-based reactivity to Angular, and we're trying to be very judicious about how much of Angular we change at once. And this is kind of striking the balance that we think is the least awkward of moving over to these new lifecycle hooks and using this new API style that is more aligned with where we think we might be going in the future. But at the same time, we are not really ready to make large changes to Angular's authoring format. And so what we have is an approach that we think is best aligned with where we think we'll be going in the future, but we're not going there yet. Now, that is not to say, like, this is kind of hinting at where we're going in the future, but I do want to emphasize, like, we have no plans of getting rid of classes in Angular, right? Like, they, like, similar to how we talked about like zone-based change detection is sticking around for the foreseeable future. We have no plans to get rid of it, no plans to deprecate it. Same thing for classes. We have no plans to get rid of them, no plans to deprecate them. They are going to be a continued, a thing that is continued to support. And if you like classes, you keep your classes, you keep using classes. And if we do go down a route of evolving this into like alternate authoring formats for Angular, it will be a purely optional thing that will be additive to the framework. So again, this is all just proposals. So we're interested in getting your feedback. No code has been written. Nothing is implemented. So We're looking forward to your feedback.
All right, Jeremy, I think we get to jump to the RxJS section.
Yeah.
And our friends the RFCs are public friends. So there's a lot of feedback about what our plans are in the comments. These are our ideas right now. Like Jeremy said, these are our ideas, but we love this feedback. So leave your comments on RFC as well so we can track your feedback. We can track your comments. And then we'll have some more time to talk about this. But I think for the team to know at the end, let's touch on what our plans are going to be for RxJS, for classes, etc., lifecycle methods, because I think there might be some conflation between signal-based components using a different pattern than non-signal-based components, and then what's going to happen next. So we'll definitely be ready to talk about that. Jeremy, we'll have you back in just a moment after our friend Dylan goes through the RxJS example. Everybody, let's give Jeremy a big shout out for all the work that he did with this. That was fantastic. Thank you for that. Jeremy, we'll see you in a sec. All right, Dylan, over to you talking about observables and signal interoperability.
Hi, Mark, and great to be here today. My name is Dylan Hun, and I'm here to tell you all about how observables are going to interoperate with the new signals-based components. So obviously, a lot of Angular apps today rely on RxJS to manage their state. And we want interoperating between observables and signals to be a great experience. So we are proposing to introduce two new APIs, the From Observable API and the From Signal API. And we're exporting both of these from a sub-package inside of core called RxJS interop. I'm going to go over each of these functions, but sort of the overall goal is that when you have existing RxJS logic in your application, you can sort of easily plug it in to these new signals API points that we're exposing. So let's go ahead and start with From Observable. So From Observable lets you convert an observable to a signal. And here in this example, we are calling From Observable with an observable inside, and we get out a signal of number. And the first important thing to know about From Observable is that sorry, it looks like my camera has gone out. Let me switch to my built-in one. There we go. So the first important thing to know about From Observable is that it manages the life cycle of the observable. In particular, when you first call it, it subscribes to the observable immediately. And the reason that we do this is because subscribing to the observable might have side effects. So for example, the subscription might open a network connection. And we want to do that immediately so that the side effects happen right at the time that you call From Observable. We also automatically unsubscribe from the observable when it goes out of scope or the context in which it's created is destroyed. So if you call From Observable inside of a component, then the subscription automatically gets cleaned up when that component is destroyed. The next topic to talk about is initial values. So observables can be used to model either synchronous or asynchronous data. And in the asynchronous case, you might not actually have an initial value coming through your observable at the time you call From Observable. And there are a couple different ways that we might be able to handle this. Here I have a little example that is sort of describing one case in which this might happen, where I have an interval, but the first value doesn't actually get emitted immediately. We have to wait for that first value. So one thing we might be able to do is to throw an error immediately when we call From Observable. So we'll check for that initial value, and if it's not there, we just throw an error. The second possibility is to throw an error when you try to read it for the first time. So if there's no value inside, then when you read it, we say there's no value, we'll throw an error. And the third option is to use something like null or undefined. So that would be like a default initial value. And that's similar to how async pipe works today. And we haven't decided on exactly which behavior we want yet, but our proposal is to go with option number 2 here, which is to wait until the first time you read it and then throw an error. And the reason for that is that in the wild, we think there are a lot of observables out there that the developer is reasonably confident are going to emit a first value, but are technically asynchronous. So they might not have done it at the time you call From Observable yet. So we think that in practice, this will be the most useful option, but we're open to feedback on this. Something else that observables can do that doesn't map exactly onto sort of the signals world is error and completion states. So observables can error and can also mark themselves complete, and signals don't have these kinds of special values. But when our proposal is that when you use from observable to get a signal and the underlying observable produces an error, we can just throw it, and then you can handle that error using a try catch block, exactly the way you might be accustomed to in other contexts. So if you don't want to do this, though, you have several other options. You could handle it on the RxJS side. Here we're showing an example of how you can .pipe and catch the error, or you can derive a computed. So here we're creating a computed that internally tries and catches this error, and then returns a special value in the event that an error occurs. So that's errors. Completion. So signals don't actually have a concept of being complete, but again, you can handle this on the RxJS side by introducing a pipe. And here we have another signal that marks is complete. And we're open to sort of discussing this on the RFC, but we think our current thinking is that this concept of completion doesn't map well enough onto the world of signals to provide them any sort of special treatment. So let's talk about the other side of this interop API, from signal. So from signal takes an Angular signal and it returns an observable. And the way that this works is that we create an effect, and every time the observable updates, we set the signal. So lifecycle and cleanup, this actually contrasts with the from observable method, from observable function we talked about above. Whereas from observable does take over management of your lifecycle, from signal does not manage the lifecycle of the corresponding observable. And there are a couple different reasons for that. So the first one is that the signal you're getting in might not actually have its lifecycle logically attached to the component. The signal could be coming from anywhere in your application. They're valid as long as anybody has a reference to them. So we should not manage the lifecycle. And the other factor is that the observable could be used in other computations elsewhere. For example, you could pass them into a switch map. You could pass them into a service and persist it somewhere else. And the last important factor is that unsubscribing from an observable could have side effects. So we want you to control when those run. As with your other observables, we don't want to do it for you. So this is why if you create an observable using the from signal function, we will not automatically manage its lifecycle. And this is in contrast to from observable. So I mentioned a second ago that the way this actually works is we create an effect. And that has certain consequences for how values get emitted. So the observable that comes out of from signal uses an effect to send its next value. But because those effects are asynchronous, all the observable emissions are async. So even the first value comes out asynchronously. And this has some consequences. So in this example here, I take a signal and I convert it to an observable, and then I set the signal 3 times. But the observable that we're looking at only ever produces the value 3. And the reason for that is these 3 calls to .set are synchronous. So they happen all in a row immediately. And then the effect runs afterwards. And the effect emits to this observable after all 3 of these sets have been already run, and only sees the last one. So this highlights sort of an important distinction, which is that signals are fundamentally not streams. If I set this signal 3 times in a row, this happens synchronously. It is not a stream of values. It's just a single value with a change notification. And then the effect runs afterwards and emits this final value. If you wanted to get that behavior, if you wanted to get the first value synchronously, you can do that on the RxJS side, and we have a code snippet showing you how to do that here. Every observer creates a new effect. So if you wanted to share your effects between all the observers, again, that is possible. And we have a little code snippet here showing how you can use share replay. Here we have a buffer size of 1 because signals only emit 1 value. And we set ref count to true so that after all of the subscribers have unsubscribed, we clean up the underlying effect. So if you expect to have a lot of observers and you want to share the underlying effect, that's possible using share replay. We don't want to do this for you automatically for a couple reasons. So the first is behaving consistently. We think it would be somewhat surprising to do this for you automatically. The second is code size. So if you want this, it's fairly simple to provide as per this snippet. We don't want to have to include this in the default implementation. And we think it's relatively low overhead. So registering multiple effects should have a relatively minimal performance cost. Okay, and the last thing I want to talk about is take until destroyed. So this is a relatively common pattern. And we're introducing a new RxJS operator called take until destroyed. And this sort of simplifies trying to do something like this, where you can just use the built-in operator, where here, as in this example, I use http.get, and then I pipe it to take until destroyed, and will automatically clean up as soon as the underlying observable is destroyed. Okay, so I think that's kind of everything I wanted to talk about. Back to you, Mark.
Dylan, that was so like, you know, you were in there so quick. I was like, oh, wait. All right, friends, now it's time for the moment you have been waiting for. We're gonna do this Q&A. So here's how this is gonna work. You all have left almost 50 questions that we haven't gotten to. These are all great questions. So for the panel, here's how I would love for you folks to do this. Because we have so many questions and we have to try to get through all of them, try to condense your answers if you can and point people to places where we might have answered them for more detail if we can, okay? Yeah, so I'm just going to start at the top and we're just going to go through it. So friends at home, if we did not get to your question, make sure you ask it, and we're trying to keep track of all of the questions. All right. So first question is, or comment, should we expect some React-like hooks or even function-based components? We saw the hooks thing, but we really have hooks, right? We have some new methods that work with signals. So let's talk about the function-based components. Should we expect that?
So what I'll say about this is, like, we've said a handful of times, and we hint at it in this RC, that we're considering alternate authoring formats in the future. Like, there are a couple of different forms that can take, and we're not really committing to anything just yet because we don't know. we genuinely don't know what that will look like yet. All of our attention is really focused on the signal-based stuff, but we are clearly looking at alternatives to the class-based authoring format. But I do want to emphasize, right, that any such change would be purely additive, and it would not replace or deprecate or get rid of classes as an option for Angular.
Okay, will Angular elements handle signal-based components?
Yeah, I think it's fair to say we haven't thought about Angular elements really at all as part of this project yet. There's a few areas still where we have a kind of our list of like other things to look into. So testing is a big part of that, right? We know we need to do kind of a bit of a sprint on testing to figure out what the story looks like for there. And I think Angular elements is a similar thing where we need to like sit down and actually think through like, okay, how does this fit in? How does that play out with the rest of the ecosystem? So it's a little bit further down the line than where we are today.
Yeah, I'll just add to that that zones are one of the things that makes elements a little complicated right now. So the idea of a zoneless element is actually fairly compelling. I think we can do some cool things there.
Okay, so how about this one? Eunice says, are you afraid of having to adapt testing when migrating components to Signal? So this is more about the migration of your components when you go from already zone-based, shades detection to signal-based. Is there some consideration for the testing story and things we'll have to do there?
I mean, yeah, that's similar to what I was already saying, is we basically have testing as a giant to-do in our like next steps project tracker. And that is absolutely going to be an important part of like the next phase of this. I honestly anticipate we're going to do another RFC just for testing by itself before we get to anywhere near final with this. As for migration, I think that's kind of a similar story where we have some ideas today about what it looks like to take some existing code and move it to be based on signals. But I think we need to, again, like sit down and go through kind of the more comprehensive, like, here's the like 40 different aspects of your code that might be impacted by signals, and like how you might approach changing each of those over to be from like zone-based to signal-based. Like we intend to, at the point of shipping anything, have very comprehensive guides and hopefully some tooling to assist for anyone who chooses to move some existing code to be signal-based.
All right, and for clarification here, evidently this was the answer to somebody else's question and not a question for us. So, but it turns out to be a good question anyway for us to get some clarifications. All right, next question. Check this one out. Can you set permanent update function to overwrite the setter?
I don't want to like override. I don't want to like steal all of the talking time, but I think in this situation, you would just create your own object around the signal, right? You could create your own like, I don't know, chaos monsters like store or whatever, and that has whatever methods, and then inside of that, that's just calling, set or update or mutate.
Yeah, I interpreted this question as like, can I set like a computation function so that when I set the signal to X, it actually takes the value of like some function of X. And I think in that case, the answer is like use a computed. That's exactly what a computed does, is it's kind of a signal that does a computation in the background.
Yeah. I mean, you could also just call a function in the setter, right? You can say set some function value you want.
Yeah. So, well, I mean, there is obviously an option, right, for mutate. That there is a large discussion on RFC. I think it's the option. It sounds like a bit more verbose, right, and less discoverable. But hey, like options are on the table. It's RFC. So if you didn't add your comment, I think you did add the comment to RFC already, so we've got it on our radar.
Yeah. For full transparency, we also considered an API, like instead of mutate, having something that was just like notify. And we kind of threw that out because we didn't want it to become the new like scope.digest.
All right, this is a two-parter, so I'm going to read both of them to you folks. All right, so if using a global signal variable, if I use it in two different components, like previously how I used behavior subject, so I need to unsubscribe from the stream. So should this also come in the picture while we use signals in multiple components? Because it looks like it's going to be a memory leak. So you kind of get the idea here. You get signal two components. Okay.
Yeah. So let me get this one. So obviously, like you can like the nice property of this whole signal system is that like you are completely free to create them where you want. Like I mean, we were showing examples where like either they were like free-flowing code or in a component code. I don't think we had an example of like a service. Like the long story short, you can create those signals wherever you want, and you can read them wherever you want. The act of reading a signal value is kind of like a subscribing, right? Like because we track those dependencies automatically. But the cool part here is like you don't have to explicitly unsubscribe. So all the benefits, no drawbacks that we are aware of.
Yeah, in our signal library, when we were designing it, one of the kind of core requirements was that we did not want you to have to do manual bookkeeping of where signals are used and destroy the signals when you're done with them. So signals don't have to be explicitly cleaned up. You can create them, you can throw them away when you're done with them. And as long as your templates are no longer reading them, then those signals can just be garbage collected and disappear. No memory leaks.
All right. Signals could be compatible with RxJS to get the best of both worlds. But we've said that this is a path that we're on where we're creating an interop between RxJS and Signals. Is that accurate? Is that a good way to describe that for our friends?
Yeah. So if you follow the RxJS interop RFC discussion that's happening, one of the key questions that's being talked about is like, should Signals implement the observable interface basically and interoperate with RxJS directly, or should it be a more explicit action to say, I would like to take the signal and get an observable? And I think our perspective is that we prefer it being an explicit action. That doesn't couple the Signal library to RxJS and observable concepts, which keeps the interface much cleaner. And there are some concerns around like the timing and how you would need an injection context to be able to use this interop library that I think don't fit very well with an implicit conversion. That could be very surprising to people if you try to like use your signal in an observable and it fails because it's not in an injection context or something like that. So this intentional, I would like to, subscribe here and convert thing A to thing B. I think is a much less error-prone design.
Sounds good. All right, another great question. Will we provide ESLint rules to support the pureness of computers? So this was a question I asked in our internal version of this, was about how can we help people see that they really shouldn't be writing to signals in a computed, etc. What can we do to support? Are we looking at ESLint rules, maybe some other compile time checks? So just walk us through what our ideas around this.
Cool. So obviously, like we're highlighting that the computed should be a pure function, but like hey, should be is not a guarantee that they will be in practice. So we do have a couple of checks in place. First, like we do inside the library detect all the writes to a signal from computed, right? Like so, if you were just like trying to, sneakily write to a signal from a computed, this will be an error. We're thinking of maybe also detecting cases where people they create other computed or effect from a computed, which is weird, but like might happen either like by error, right? Like maybe not intentionally, but it might happen accidentally. So that might be a check. Then pureness, I think it's absolute terms is like very hard to detect in all the cases, right? Like you might have as an example, you might have variable read that behind the scene is a getter that will have some side effects. So we will never be able to detect all the changes. We might have some rules and checks in place, but it will never be 100% guaranteed. I hope still that we can cut the most common sources of problems.
Okay, excellent. All right, let's go to this question. Also, set/updates treats objects as arrays as if they always change, right? And only runs equality for primitives?
That's correct. That's exactly the case. And again, this is because we wanted to support people that prefer to use mutable data, right? Like if I prefer to just change the content of an array and have this change propagated, that's kind of from where the default equality comes. We do have it covered in the RFC. Again, it's a request for comments. That was the current thinking,
All right. So I know I repeat myself and Asma already nobody's question. Nobody's annoyed, Cast Monster. You're asking great questions. We actually talked about this, but we are looking at ways to help developers and experience to provide tools around to avoid things like loops with effects, right? So what are our ideas here, just in general, just a little bit more on that one?
Yeah. So I think like we talked about computeds, but similarly to computeds, we did introduce a check in effects that you are not writing to signals, which is, I guess, the main source, like potential source of loops. But again, that's hopefully will eliminate the vast majority of situations where people get into trouble. At least this is what we saw initially. The people like, oh, I'm going to write to a signal from an effect that maybe this effect like reads this signal back or maybe through a computer and whatnot. So hopefully this eliminates the major foot gun. Again, like it's very hard to prevent all the I don't think we've got ambition to prevent all the infinite loops in the world. Like rather, I mean, if I would know how to do this, that would be great. But there will be probably situations. But again, the vast majority should be addressed by preventing writes to signals by default.
Yeah,
I also think it's. Oh, go ahead.
Yeah. I'll say I'm also keeping a running list that is, I think, at like 12 to 14 items now of like, here are some anti-patterns that might emerge or practices we might want to discourage with signals. And let's think about ways to try to not let developers fall into any of them.
Yeah, absolutely. What I wanted to add is that effect as an API looks really interesting and really tempting. because it is the point at which like, oh, I can do something when signals change, and that's interesting. In reality, I think most of the use cases and applications will not require effects. Effects are kind of a specialized tool that you reach for when you absolutely need to do something kind of imperative outside of the normal flow of rendering. So it's a implementation tool for directives. It's an implementation tool for some of the interop story that we have. I think it'll be pretty rare that you end up reaching for this thing inside of a component. More often than not, you'll be using computeds, or you will be using one of the other lifecycle hooks to kind of do things at the right time in your application.
All right. So do you have an idea how new projects will be generated in the future? Will you just get a prompt in the CLI to choose between starting a new project with Zone or without Zone? I have some ideas about this, but I do want to hear from you folks first.
We haven't gone that far yet.
So the reason I have some ideas about this because I'm writing something for you all to review, because I've been thinking about this as I've been working on stuff. So I expect something, not you folks at home, but this panel to see something coming from me to review about ideas about this. Okay. But we are thinking about it. We just haven't gotten really far to the planning phase, but we are thinking about this type of stuff as a team. All right. This is funny, but I think the intention is good. Will effects create effect tail? So I guess it's the pattern that you see in other frameworks where you just kind of overdo it with your effects, and then you kind of create some anti-patterns. What are we thinking about how we can support developers to avoid anti-patterns with effects and some of the new things we've announced?
Well, we'll have to publish Jeremy's list or like ship it to everyone. No, more seriously, I think like this is a new system, and we are kind of collectively discovering and learning it. And as the more applications are being created, I'm sure that best practices will emerge. But what I would like to say for this initial learning process is just like, remember that effects exist, but try to use it as late as possible. Like really, the signals are great at deriving state from another state, right? Like computed should be a main tool in your arsenal. So every time you feel like reaching out for effect, and especially when you think like, oh, I need effect and I need to write to signal, just like some lights that should start blinking. It's like, oh, maybe I should like reach for other tools. But I guess it's a collective learning that starts now.
All right, this is a really, really important one. Our backwards compatibility story is legendary in the industry because we really try to add things and bring along everyone else. So how long will backwards compatibility be maintained? How much time do we have before we have to refactor current apps and libraries?
Yeah. So I'll say like we have no plans to, again, like deprecate, remove, or otherwise like get rid of the like zone-based components. Just like they will stick around for as long as into the future we can predict. Right? Like I won't necessarily say forever, because forever is a long time and we don't know what will happen in 5 years, 10 years, but we fully intend for those to stick around and keep working.
All right, I think we kind of touched on this, but we can just do a couple of sentences here. Can you use methods in computed, and will it still track signal changes read inside that method? Right,
yeah, exactly. Like you can, like the only thing that matters is the read of a signal in the same JavaScript stack frame. Like so, if you've got the chain of calls, the signal read will find it's kind of computed to register itself as the dependency. So the short answer is absolutely.
Okay, good. So disalign writes to signals and effects just in the same tick, I assume. I'm not sure what this question means, but
well, I mean, it's in the same JavaScript stack frame. So like it's like you effect will like put itself on a stack, and it starts executing your effect function. And if during execution of this function you try to write to a signal, but if you start some asynchronous processing, obviously you are free to write to signals.
Okay, will the previous effect cleanup run when it runs next time? I think in the RFC it says cleanup runs only on component destroy.
It's both actually, right? Like, so if you don't destroy an effect, the cleanup function will run just before next step. So again, this is this idea of like, if there's any work to stop that was started by the previous effect run, that's your chance of cleaning up, right? Like, so this is this part of before the next time. And then obviously if someone says like, oh, hey, effect, I don't need you anymore, then where we also want to do stop the current work in progress. And this is where we do cleanup. So in both cases, it will run.
Okay, great. All right, this is great from Akshay. It says, let's say my Angular app is large scale. If we decide to create new components using signals, however, the old components will still be zone-based. As a dev, what would be my advantages of starting that new signal component?
It's a good question. One that I think Alex or Pavel will answer better than I will.
I think like everyone will have a different list of things, but go ahead. Alex.
Yeah, no, I can take a stab at it. Today in Angular, especially for large scale applications, we see a lot of people reaching for on-push change detection as a tool to kind of manage the work that change detection is doing and communicate a little bit better with the framework that, you know, only specific components need to be updated in response to specific model changes. Signals, I would argue, are a more ergonomic solution to this problem. They don't have some of the sharp edges of on-push, particularly around how on-push kind of shields children from change detection, even if those children may not have opted into the on-push model. As well as, you know, marking a component for check in on-push marks all of its parents all the way up the zone tree to the root of the application, because change detection has to reach that component in order to check it. That is not true of signal components. So if you change a signal that affects a signal component in a zone application, that signal component can change detect even if no other component in the application is marked for check.
All right, this is a question for Jeremy specifically. Can we have, for 1 second, appreciate Jeremy's adorable dog in the background? Yes, we can. It is adorable that your pup is just chilling out.
Yes, that's Mal. And if you'd like to see more of him, you can go to the website, mal.dog, mal.gog. I put it in the chat, except I'm shadow banned for some reason.
Mark. I would have fixed it. I'm going to fix it at some point. Oh, wait, let's keep with these questions. Will we be able to have signals and async streams in the same template?
In on-push components, absolutely. In signal components, this is an open question for us, whether we can make the async pipe still work. There are some questions about the change detector ref and how that will interact with the signal change detection that we need to figure out. But you can always use the from observable operator to convert your async stream to a signal, and then read it anywhere you like in the template.
Will HTTP client method return a signal?
They will not. HTTP client is a great example of an actual stream of events. This is something where you're being notified at a point in time that something has happened, right? This response has come back from the server. Signals really are values that change over time. So it doesn't make the sense to ask the question, like, what is the value of the HTTP response before the response gets back? So I don't know what HTTP client will do in the future. Whether we want to explore, you know, some kind of fetch-based integration with it, or whether the current XHR backend will survive, but it will not return signals.
Okay. Do we have any stats available about some change when we switch from signals, from zones to signals in terms of performance?
Not at this point, right? Like we see how much change detection runs in big applications, and as the anecdote, I spend a lot of time profiling in scope of other work, but it's not uncommon to see applications that run change detection 1,000 times. And I know some public and well-known applications that do this. So it is not anecdotal, oh, maybe this change detection is expensive. Actually, you can see it on the profiler very clearly.
All right, friends, we have a little bit of a dilemma. We have 28 more questions and only 10 more minutes scheduled for the stream. So I want to ask you to keep your responses as quick as possible, within reason. We'll do what we can. We do want to give people their answer they've been waiting for. We were previously told that we can make signals and Zone.js in the component itself. I only see a Boolean switch between signals and Zone.js. How can we achieve them both in the same component?
Yes, you can use signals inside of zone-based components, but you don't get the signal-based component APIs, right? So like the signal-based component APIs, like input, model, things like that, those are like on-off, but the concept of like signal computed in effect, you can use anywhere, even outside of components.
All right, so do we have a plan for template variable syntax that will solve for the absence of type coercion when calling signals in a template?
I don't think there's one plan. I think there are many ideas. So template type checking is entirely under the Angular compiler's direction. We could make it so that signal reads are type coerced properly. That's something we're looking at doing. Obviously, the trade-off there is that they would behave slightly differently than control flow in actual component code. Another option here is to introduce some kind of like template variable syntax, which is a feature request for other reasons. That's something we would be open to talking about doing. But yeah, we're exploring kind of multiple avenues to solve this problem. And again, this is an RFC. Maybe the result of the discussion is that we do actually want dot value for this reason.
Okay. Are computed properties preferred over pipes?
I think pure pipes, like the computed are so much nicer experience as compared to pure pipes in terms of creation and how they behave. That I would say yes.
Is there any reason why input couldn't support RxJS as well as signals or any of the other existing means of passing inputs?
Is a complicated answer that has there's a lot of reasons for why. Like, so obviously we've had a GitHub issue for a long time that's like, I want observable inputs, and what we have is not that, right? Signals is not observable inputs. It is signals as inputs and an API that if you want, you can create an observable from that input, which is our way of a kind of roundabout solving that, but also solving a lot of other problems at the same time. And because we're short on time, I don't think we can get into all of the reasons for them, but that is kind of we intend the RxJS interop story there to be the answer for this.
All right. So let's keep going here. Does the current setup lean more to passing down signals between components, or each layer of components creating their own version of signal and using these inputs?
There is no leaning here. Like you are free to, as I said, like you are free to create your signals where you believe the source of data is. So like some signal needs to be shared between components, put it in a service or wherever else. If it's a local state to a component, put it in the component and just like use signals in template as you would do, and we will take care of the propagation of change to the components that are reading and are interesting in the change of the value.
Okay, how about this? How will a component factory know about a component's inputs and outputs if they are not declared via decorator?
Our compiler doesn't actually, our Angular decorators don't actually execute, right? Our compiler looks for the presence of these things on fields and compiles the component based on the information that it extracts from the decorators. We can extract the same information from seeing the input function on the right-hand side of a property.
So is it possible to pass the signal function itself in the template instead of calling it? This will allow the compiler to check if a binding is a signal and update just that binding instead of the component.
I think the so like function or the signal that you don't read is just like a reference to an object as any other JavaScript object. There's really only one rule in this system. Like if you read a signal, this is where we kind of connect the dots and say like, oh, this component needs refreshing. That's the only rule. If you keep passing it down, like nothing happens.
Okay. The banana in the box, so square bracket parentheses syntax with sugar for event emitter and inputs, which was async, I think. So the behavior with the model will change?
Yes, the idea behind model inputs is slightly different than the two-way binding concept we had before, where it was just a desugaring of a property binding and an event being emitted. So that is slightly different. The first draft of the RFC even had a question, or like a discussion point about the API for this, but we cut that out as not being the most germane to the like core concepts of Signals.
Will reactive form support Signals?
We definitely think that Signals are going to impact forms, but to be honest, we haven't really gotten yet to the point where we're deciding exactly how. So at the very least, we'll want to expose things like the value as signals, or the validation state as signals, but we haven't decided exactly how.
Excellent. How about this? This is a good question. Does that increase bundle size? Because we're keeping both patterns.
We'll see. Well,
We'll
like
see.
the good news is that the IV instructions are like by design tree-shakeable. So we've got this ability of a compiler just outputs as the compilation results things that I use. So probably we will be aggressively leaning on this mechanism. But hey, sometimes we might have some if-else that will be not shakeable. We'll see. We will keep an eye on it, and definitely not planning to increase the size of the framework.
Yeah, what I can say is like we're always like very aware of the size and making judgment calls as we add things on whether or not it's worth it and what we can cut out elsewhere.
All right, so here's some honest feedback. Let classes be classes. Leverage the full power of classes. Keep class syntax classy.
Yeah.
So this is context.
I'll repeat this again, right? Maybe I just can't say it enough. Classes aren't going away. If you like classes, you can keep using classes. We have no plans to get rid of them, and we know a lot of people choose Angular because you do like them. We also know a lot of people don't choose Angular because they don't like them. So do with that piece of information as you will.
Yeah, and just maybe to add to this, like I think like we are going, classes versus functions, like this is not binary choice that we have to do. Really, what we are looking at, like what's the best developer experience that we can create with the pieces that we've got at our disposal in JavaScript syntax. So there is no religion here. We are just like trying different things and trying to settle on something that works, that we believe works the best for developers. But since the RFC, like it's great feedback to have.
Okay. We got a couple more questions, and then we're going to call it a day. So I'm a huge fan of DI, dependency injection, and IOC, inversion of control. Huge proponent of SRP, SOC, etc. So Angular implicitly supports all of these, and it was fundamentally designed on all these long-standing sound principles. Are we moving away from DI and IOC?
We love DI.
No. Nothing about this changes DI at all. Like the totally separate mechanism, totally separate system, unimpacted by Signals. And in fact, I will say, I think Signals actually works even better with DI because the signal-based model we've come up with, you can use it anywhere, not just in components. You can use signals in your injectable services and what have you. And the reactivity model between all of your injectable things and your components and your directives all just integrates nicely through the whole system.
All right, here's our last question from Alexei. When is this going to be released?
That depends on the feedback we get, honestly.
But I think we can say, what can we say about when people can try this? Do we have any information about that?
We can absolutely talk about V16.
Yeah. So in V16, there is a developer preview of the signal primitive, right? So that is the signal computed in effect. And there's a way where you can use those in Angular, and they are tied into Angular's current change detection system, which maybe, Alex, you could talk a little bit more about. For the rest of it, for like the signal-based components and all of the like more like granular change detection, that will be at a later date, which we won't commit to anything today.
Yeah, in V16, signals are in the framework. You can use them. They're under developer preview. And if you read signals in on-push components, signals will mark those on-push components for check. So signals kind of integrate into the existing change detection story in a way where you can use them to drive change detection in the same way that the async pipe drives change detection with observables. And so you can kind of play around with the signal experience. The RxJS interop layer is there, so you can play around with converting signals to observables or vice versa, and kind of use that to see a little bit what signal change detection will work like when we have actual signal components.
But developer preview, things will change, timings will change, things will change. We got to like make sure we're super clear about that. There are still lots of things that we're deciding as a team. Is that correct? Like still lots of parts of this. So this whole conversation was us just sharing with you what our thoughts are. This is what we're thinking about doing next. We're going, your feedback is super valuable. I think we're really grateful just to see everybody's feedback. So thank you for that. Hey, friends, Dylan, Pavel, Jeremy, Alex, thanks for hanging out today and talking with the community. This was fantastic.
Yeah, and thanks, Mark, for indulging us in our last-minute put together live stream.
No, you folks are fantastic. All right, friends. So at home, this is a recorded live stream. If we did not get to your questions, add them to the RFC. We're trying to reply. We're reading at least. And yeah, so continue to be great and kind to each other and do us one big favor and go build great apps.